Good evening everyone and welcome to the Q&A session 13 from the chapter of circular motion. The topic is the calculation of optimum speed for the circular motion on a rough surface. So based on this topic, I have selected one question from one of my books, and the question here is: a circular racetrack of radius 40 root 3 meters is banked at an angle of 30 degrees. So if the coefficient of friction between the wheels mean the wheels of the racing car. If the coefficient of friction between the wheels of the racing car and the road is 0.15, then the optimum speed of the car to avoid wear and tear of the tires is. So there are four options here and we have to find the correct option, and here the value of G is to be taken as 10 meter per second square. Now in order to avoid the wear and tear of the tires of the racing car, the frictional force should be equal to the centrifugal force, and here the frictional force is the force which is providing the necessary centripetal force in order to move this racing car in a circular path. So the frictional force should be equal to the centrifugal force in order to avoid the wear and tear of the tires. Now the frictional force is equal to mu n. N is a normal reaction, and this is equal to, and n is equal to m into g. So mu mg, and this is equal to, the centrifugal force will be equal to mv square by r, where r here is the radius of the racing track, v is the optimum speed which we have to calculate, m is the mass of this racing car, and mu is the coefficient of friction, and g is the acceleration due to gravity. From here, the optimum speed of the car will be equal to under root mu r g, and we also know that mu is also equal to tan theta, where theta is the banking angle. So in this case, the theta is equal to 30 degrees, so mu will be equal to tan 30, and tan 30 is equal to 1 upon root 3. So from by substituting the value of mu, r and g, we will be getting the optimum speed of the car in order to avoid the wear and tear of the tires, and this is equal to, mu is equal to 1 upon root 3. The radius of the racing track is 40 root 3, and g is to be taken as 10 meter per second square. So from here, v is equal to under root 400, and this is equal to 20 meter per second. So the optimum speed of the racing car in order to avoid the wear and tear of the tires will be is equal to 20 meters per second, and the correct option here is A. So thank you very much for joining this session. Now in the next session, I will be coming up with a different type of a question in which we will be discussing the maximum speed of any body which is moving in a circular path in order to avoid the slipping. So till then, have a nice day. Bye.